and welcome to Agentic AI in DevOps. I'm Fernando, and with me are Vladimir and Andrey from Sirob Technologies, where we build Boris, our Agentic DevOps teammate. So in the news today, we are going to talk about OpenShell from NVIDIA, Cursor 3.0, and we are digging into the Claude Code leak. So we are going to see what showed up in the source code and all the discussion that's going on about privacy, telemetry, and what the coded agent is allowed to do on your machine. Next, the main topic of today is harness engineering. So harness, you can think of it as a horse harness, right? So the models that we use from Anthropic, from OpenAI, they are the horsepower, they are the intelligence, let's say, while the harness is what connects the work that you want it to do, and basically it steers the model so it does actually what you want it to do. So Codex, Claude Code, Open Code, they are all the same story. So the models are behind the scenes, and we use a harness to get to the point that we want. So these are the topics of today. So let's get the show started.
Let's get started. Vladimir, do you want to tell us about OpenShell?
Yeah, it's something that came from NVIDIA, and I think it's related to an Nemo claw. If you're familiar with OpenClaw, there's tons of claws on the market. I can also recommend to try the Nemo claw and see how it works, but beware, it's a very secure and very constrained, so it's probably not going to work since day one. As soon as you run it, you run the Nemo claw and it can't work. But it's maybe because it's of a OpenShell, which is used for the sandboxing, and OpenShell actually work across 4 different layers. It's a networking, file system, process, and interface. And all of them can be enforced in a one YAML structured policy schema, which is quite cool, especially if you worry about the security and worry where your agent's going to go. So, and I think for a network part, it's also important if you have some kind of constraint and you don't want your agent to go outside to a wild internet somewhere. We can recommend you to use NVIDIA OpenShell and use it for sandboxing.
We're bringing this up because there are a lot of people around us talking about constraining the agents, right? So you have the agent running locally on your machine with access to a file system where you might have or might not have secrets or sensitive data. It might run commands on your behalf with all your permissions. So, and the prompt injection is a real possibility. The malicious skills are out there to get you. Supply chain attacks are out there, getting scary. So LLM can easily step into those traps, which means that people are thinking, how do we contain the threat of the agent doing something we would not it to do? Like if you read Harry Potter and there is a Tom Riddle diary that leads a little girl to do bad things, it's exactly the same thing. I'm reading a lot of books to the kids.
Yeah, very good, very interesting reference. Good one.
So the OpenShell is one of the ways of like how NVIDIA suggests you contain the agent and elevate your security posture. I think that a lot of people now looking at the dev containers. And before show, Vladimir had something to say about that. The dev containers, Docker, using Docker for security?
We discussed it briefly with Andrey. Like as all the DevOps engineers probably know that the containers are not actually built for the security. We build it mostly for isolation and for packaging things. But now it's kind of a common understanding that everything I put inside the Docker container, inside the container, it's automatically secure and 100% isolated, which is not. And it's not that hard to escape, especially if your container is running as a root user, to escape from it.
I have like a full operating system on there with all the tools to live on the lab, like with the CVEs and those tools. So the container escape is, I can't say it's trivial, but it's something that people do routinely.
Yeah, and if you think depending on what you want the agent to do, you still need to give it some access anyway, right? So you try to contain the run time, but you still need access to files and things for it to be useful, right?
Also, look, like a lot of people today just using the agentic coding tools as a shortcut for the system configuration. because they know where your config files are, they can edit them, and they're very good at it.
True.
How good they will be from the like if you ask them to escape the container? I think it might be quite capable of doing that. So you don't need to be like very clever to try to pull that off. So
yeah, it's true, right? I have seen some stories like a guy he just asked, "Can you connect to my Sonos on my network?" Right, the speaker. And he started sniffing the network and finding a way, and then suddenly the guy could control from Claude Code his speaker. So indeed, like if you ask it, it will find a way, right?
I mean, the Docker container is better than nothing. Let's put it this way,
true.
right? There is at least some permission segregation, and there is like the hoops that people need to jump to get out of the container. And security is all about layers. Like you don't rely on one single layer. You want to layer it. I always say like it's like like Shrek, like an onion. You want to peel and cry while you're peeling the layers. So this is exactly what you want to do. But enough of OpenShell. What else do we have in the news?
Yeah, I think the next one is Cursor 3.0, right? So this is an interesting one we were discussing before as well, right? And we have seen like one of the very interesting parts is the focus on the full agentic view, right? And like moving away from the IDE, the file tree, and actually having like a terminal, built-in browser, chat in the middle, and then the agents on the side. You guys also mentioned, right? Like very similar to Codex and other tools, CMux.
Yes.
So that's interesting. I mean, I stopped using Cursor in the last month, so for me it's nice to see that. I don't know for you guys if you had like some more experience with this. Well, with this interface. For me, I still being very open. Like I still like to see the files. Like I use more maybe the VS Code style where I use the terminal, the things, but I still want to see things. So maybe it's a transition from the engineering to like this thing, but I don't know how it is for you guys.
What's your take, Vladimir?
For me, like it's less technical people to still do more technical things or work with content and with their job functions in a coding way. When we use Git, for example, which no one understands, and people can save different versions, go back and forward, do some blog posts, do presentations, and do all of these things which in the past was available only for some tech geeky people, so not anymore. And UI is always nice. I don't know. I actually use similar thing from the Codex. So for me now, Codex and Cursor are kind of equal in the plugins, in UIs. I don't see much difference, and the pricing and everything. You can use different, but it's the same thing. I can also recommend to use a nightly build of Cursor, and you will know all of this news in advance. That it's quite stable. So I'm updating the Cursor basically every day.
Yeah, they ship super fast, right? I remember when I was heavily using Cursor all the time, like updates available, click to restart. It was like, wow, these guys are like super. And it just crossed my mind. I think where I started seeing a lot of this new, let's say, interface, really agentic focus, was when anti-gravity came out in Google. And like and if you see online, a lot of the AI automation people started to move into anti-gravity because it was this feeling like, wow, these things write code and I don't have to look at it, right?
Right.
Which was interesting. Now you see the whole industry kind of go in that direction as well.
Yeah, Cursor 2.0 was playing with that. So they had this agentic pane where you don't see the code. It was kind of getting in your, they were trying to push it in your face all the time. And I felt myself going back to the like more of the Visual Studio Code kind of view. But I find this new view that they have, and for people who haven't seen, I will just briefly describe it. So you have one pane on the left where you have all your workspaces, and you can run parallel chats in those workspaces. In the middle pane, you have your current chat that like you activate, and on the right you have like a terminal and a browser built in. So if you've seen CMux, it's like CMux, but it's actually much more polished. Like I tried CMux myself. My feeling was it was kind of laggish a little bit. So it was kind of slower and not as polished. I mean, to me, Cursor still is like driving BMW. Like when it comes to the UX, Cursor is like driving BMW in a coding world.
I now have two things. Like as first thing, I usually run about 5 agents in parallel, and in the previous version of Cursor, it was a tiny window on the right. It's just not useful. So, and then the big screen is why in the past I prefer Codex more, because it's one big screen, so I can switch between the agents. And now it's a bit better in the Cursor, but also like a speed, how fast is the development environment? I think it's very critical now in the agent world. There's a couple of more development environments which we may discuss later in the next episodes, and there's one which is faster than Cursor. Maybe we can talk about it later. So.
Subscribe, like subscribe.
Exactly.
Watch
coming up in the next episodes. Nice.
Right. Maybe enough of Cursor. The last news we have today, the last shell bomb, we should say.
Yeah, this one made shockwaves around, right? In the Claude Code leak.
We should not call it a leak. Let's not call it a leak, because there was a lot of I would say sloppy journalism done there. But I would say it was an intentional disclosure. That's like it was like a packaging mistake, basically.
Yeah,
it was an intentional disclosure. It wasn't like a malicious, like
not intentional.
Yeah. So the leak is usually used in a more malicious context, and there was more like the packaging mistakes that made the source tree available for people, and the people were like running around doing the analysis of that. There was a bunch of the repositories thrown out with the copies of it. Anthropic is doing its best running around trying to squash all of that, sending cease and desist notices, which is understandable. I think I seen the numbers, which like takes them with a grain of salt, and don't quote me on that. That was like a couple of $1 million spent in tokens just to build that whole thing. So, and now you just like showed it to everyone, and you have a lot of other agent harnesses like Claude Code that now can peek into that and see how they're doing things.
Yeah, exactly.
And I think that's like the most interesting part, because it will give a boost to other open source, and not only open source agentic harnesses, because they can peek into what Claude Code does. And I don't think the Claude Code is the best one out there, but still, it gives an idea of people what's possible. And like, for instance, even us, we're also building agentic harness called Boris. So we, like the same as the rest of the world, we actually took a look, like what is it they're doing there?
Yeah,
with, quite a bit of interest.
There's a lot to leverage, man.
Who get like as the biggest benefit of all of his disclosure and so on, it's the end consumers, because all of us get the better features, because it's increase how people are compete with each other. Yeah, so we will get the better agents in the end.
In a way, it feels like open source code, right? That inspires other people with ideas and say like, oh, I like this, maybe I can tweak a little bit and make it even better, right? So
Yeah, it is really good. It's like, it reminds me the container wars. I mean, like container orchestrator wars 10 years ago, but now it's just moving much faster, right? So people building stuff because they have a capability to build it and like be more like of the project manager. And another thing that you might notice is that all those agentic harnesses, they're converging to the very similar shape and form. Vladimir mentioned that Cursor looks like Codex looks like anti-gravity. So I mean, like, we are converging to somewhere. Like, there is still quite a bit of experimentation going on. Like, and I do give credit to Cursor, because they do push envelope with UX, and they're experimenting a lot with UX. I do think they were like first pushing this agent-only view. Keep going, guys. You're doing great. But for the CLI tools, like there is Open Code, there's like PDev, PIDev, and there's like a lot of them who might now take a look and see how the Claude Code does things. We do have a small list of features that some of the kind of being mentioned a lot, and that can give you an idea of what's coming. So there is something called Kairos, and it's described as a proactive Herbert-style loop that runs in the background. So think of that similar to OpenClaw. I guess they're going to make their own OpenClaw. Auto-dream, basically, like when we're dreaming as a humans, we consolidate our memories. So Claude Code is kind of doing the same. The memory layers, so it's the people got a view into how Claude is managing its memories. You don't really need to look into the code because most of that is on the disk in the .cloud directory. If you never looked, all the memories are there. And there are anti-distillation and decoy tools. So they're trying to prevent people from the model distillation. And model distillation is when you use another model to train your model by asking that model the questions and trying to reverse engineer its weights, pretty much. Yeah, there is like some Easter eggs, like something called Body, which is now, I think, already available in Claude Code by now. I think they already released. There was like many more things hidden by the feature flags. There was a lot of discussion of like the telemetry and like, do they look where they're not supposed to be looking? But there is nothing that would point to foul play, and everything seems to be going on according to the official Anthropic docs. They say like we use Sentry, we use StatSeek. Sentry says it on the website, like the Anthropic is our customer. StatSeek says like Anthropic is our customer. So it's like, it's not a secret that they're using those, and they explicitly specify that they do not send like the prompts and the customer data to those tools. Those used for the feature use tracking and the error tracking. So I'm curious how do they make sure that pieces of customer information is not sneaking into the Sentry errors, because time to time in Sentry stack traces, not on a purpose, but you still might capture the part of the customer information. So there might be something there, but like that's just my speculation. Maybe they have some clever system in the place.
Yeah, and I think like one thing that I saw that's very practical for anyone using it are the slash commands, right? That are built in. Like there are many of them, and even very useful stuff like a security review. So there's a whole built-in slash command that looks at your code and finds security holes, right? So you don't need to you don't even need to build anything. You can just run that command at the end of your implementation, for example, and then it's just gonna do those kind of things. There is review, there is ultra plan, is an interesting one if you're building something super big, but I saw apparently pushes your codes to Claude's infrastructure, right? It runs the plan there with more capacity. But apparently there are like 85 slash commands built in, like a lot of different stuff that most of us don't use and maybe don't know that are there.
This one, like so always built-in commands and tools is the biggest difference between all of its agents which is available on the market. So basically you're choosing a set of skills, plugins, and tools which is built in.
True. Yeah, I think this is one of the core insights for people indeed, is to look at it as a full ecosystem, right? With the tools and the things. Sometimes I still see people thinking of it as like maybe a fancy chat box that can do stuff, but there is like so much power into that thing, which really is a good segue to the harness discussion,
the main
right?
topic,
because that is indeed the point, is the value that these tools can bring, right?
Exactly. So the main topic today is harness engineering. Fernando already gave us a breakdown of what harness is. It's basically those tools that you run on your machine that's being called harness, and this term starts to gain prominence now. The harness engineering is what people do when they build those tools running, and the harness is basically that you have agent like Claude Code. You install Claude Code, that's agent. So everything that's not as a model is a harness. That's how you can think of it, right? So basically that everything that wraps around the model and allows that to interact with your computer, all the memory, all the system prompting, all the tools that have, all the slash commands, all the clever stuff that they do there. That's like all the harness. And how do you build the harness? That's the new chapter in engineering, if you like.
Yeah, I think that is what makes the difference between like when you try to use these tools and you get crappy code, generic stuff, right? Or when it, let's say, code something the way that we would do, right? And many ways to do it. One thing that I leverage a lot that connects with this, for example, are custom skills, right? So things that I would do in a certain way, and then I can build a skill that works as a harness to drive the model so it does the thing the way that I would like it to do. It's similar to the analogy we said with the horse, right? Like the horse can be super fast, but if you don't guide it, it is going to go in whatever direction it thinks it should go, right? And with the model is the same. Then it starts making decisions without involving you as well.
There is an article that came out last week, or it's like guest article on a Martin Fowler blog, which Elk actually called Harness Engineering. We're going to have it in our show notes on the website, so you will be able to find it there. Also, like, it will be under the YouTube and wherever podcasting platform you use. So we're going to be quoting from it. And one quote that I want to mention is, well-built outer harness serves two goals. And there they actually define two harnesses in there, right? So they have like outer and internal harness. So there's a user harness, let's say, which is feed-forward and feedback controls put in place by the user of the coding agent for their particular system. So this is all your skills, prompts, hooks. Stay subscribed for the hooks. That's, I guess, coming next as the next episode. And then there is the harness itself, built by the coding agent, built by the provider of that coding agent. So this is what they mean by the outer harness. So a well-built outer harness serves two goals. It increases the probability that the agent gets it right in the first place, and it provides a feedback loop that self-corrects as many issues as possible before they even reach human eyes. Ultimately, it should reduce review toil and increase the system quality, all with the added benefit of the fewer wasted tokens along the way. So that's like, they basically have in an article, they give you the two different systems that allows the agents to produce the good results. So you have the feed forward, and that's something that you provide to the agent. Like, as I mentioned, the skills, the how-tos, the rules, maybe access to the language server, and so on. So something that the agent can feed in before it generates. And then there are sensors, something that can provide the feedback to the agent about what it generated. And you can think about that as a static analysis, unit tests, checking logs, looking at the website if it's building a website in the browser, and like maybe running review agents, which are more expensive, so you want to maybe to do it less of them. So, and there are also two types of guides and sensors that they propose. Computational, those are deterministic and fast, run by the CPU. As I mentioned, test, linters, type checker, structural analysis, usually runs in milliseconds to seconds. Results are reliable. And then there is inferential, which is semantic analysis, AI code reviews, LLM as a judge, usually runs on a GPU and NPU. Those are slower and more expensive, and results are less deterministic or non-deterministic at all. And this kind of nothing new, really, if you look into the way we've been doing CI/CD. So CI/CD is the same, right? That the pipeline, you're getting the feedback, making sure that it's something that goes through the pipeline and meets all your quality criteria. And you usually have this testing pyramid where you would have like the unit test that like you run all the time, so it's cheap to run, fast to write, and then you would have end-to-end tests on top, which are brittle, hard to set up, hard to write, hard to maintain. So that's like also expensive to run. So that's like LLM as a judge. Kind of very similar, but idea is here that your harness allows interaction. So it first of all has all those technical capabilities to improve generation process, which means like a RAG, right? So like the memory. So it gets all the data it needs before it generates. So it understands you well. And then while it generates, while it's like running the generation loops, like it's called agent loop in many ways. It can also self-correct through different means.
I think here for me, what was really cool and maybe make it more clear is that we can integrate the things we already use for quality before, right? Like you mentioned, the tests and all that, and bake that into the way the agent always works. So you can use, let's say, the feed forward, so the instructions to say, as an example, always write unit tests, and we need to have, 95% coverage, right? So then that goes as an instruction, and then it writes a deterministic thing to validate if that instruction is met. So then you kind of keep at least some more deterministic checks and balances against the output, rather than just the agent saying like, hey, I completed the task and I hope it is okay, right? I mean, it works. So it's a very interesting thing to understand, and then balance between these two, right? How much can we put of deterministic checks that are cheap, the computational ones, and then instead of leaning too much on the inferential where it's more expensive, right? Everything is a token, like if you plus, it takes longer. So it's a very interesting way to improve whatever output you're getting out of these agents.
You also probably heard about people talking about using different harnesses or agents. Those might be interchangeable as words. And getting different kind of results. And this is like they would use the same model in them, but they will get a different result. That's exactly because of the harness and all the clever engineering that goes in there. So that yes, you can have the same model, but the harness itself makes a lot of difference, and that's why the Claude Code unintentional disclosure makes so much splash in a open source community, because people are able to look how they do it and improve what they build. And also there are different how it will behave in a way. Like I just want to give you an example of Claude Code, which is well known to disregard instructions. I mean, like it just ignores AgentsMD or CloudMD quite often, like the people complaining about all the time. And then you have like something like Kiro that actually like very strictly follows steering rules. And that's like built within the system prop and the harness itself, and also the way how it checks itself is like if it's following or not. Another thing, like if you compare like Claude Code to Kira, like I'm using both quite a bit, the Kira is a TDD heavy, like it's really TDD heavy. It really likes to write a lot of unit tests before it does anything. And it's like leaning heavily on unit tests to self-correct. Claude Code is kind of doing unit tests, but my feeling with Claude Code that is like doing unit tests as a developer would do. Like a typical developer. Now I've wrote all the code, maybe I should do some tests. And it will like do the sporty tests here and there. But like the Kira is like very thorough when it comes to the unit testing, and it's leaning heavily on unit tests. Like when you develop with Kira, you're actually getting tons of unit tests. They might not need as much really as it generates. Like with Claude, you get some, if any. With Claude Code, I mean.
True. Yeah, my experience was the same, and I think with Kiro, then it's interesting that if you want a bit more speed, it can be frustrating, right? You're like, oh man, again, it's going through the whole loop of things. With Claude Code, I saw indeed you need to really tell it that you want it, right? Like it needs to be baked in, because indeed it doesn't come from the inner harness. Let's say it's not it's not that strict internally.
It's not
right?
how it's prompted, or like whatever it's using to determine the course and how it works. And then like when you apply that to DevOps, because it's like agentic AI in DevOps, we haven't spent that much time talking about DevOps, did we? So then this is where the harness matters, like the kind of harness you use, because it's first of all tools and access. Like for instance, if you are troubleshooting the live system, does your harness has all the tools to do a good job and figure out, like for instance, can it do a DNS lookup? Can it resolve the IP addresses and stuff like that? Can it get access to the log somehow and like check the metrics? So, and you would notice that the tools that they use might be different. So for instance, I'm comparing for instance, Kira CLI, which used to be Amazon Q. So that would have a built-in use AWS tool, and it can also run the AWS CLI commands. Like the Boris, the stuff we build, have like a tons of AWS tools for every particular thing, and like that makes it better in doing what it does, because there is like a lot of knowledge built into those tools. Like this is where the knowledge comes in, and specialization, like through the tools. Because when the model call in the tool, if it's a generic tool, like for instance, if it just runs open source tool, right? And or like the CLI, I'm on CLI tool. For instance, you're using like AWS CLI for troubleshooting. You're running Claude Code, you're telling it like, well, go do the AWS CLI, troubleshoot this. For instance, you're troubleshooting ECS. For instance, you want to get the ECS service events. If you ever try to get ECS service events from API or CLI, you know you will get a lot. There is like no pagination, no nothing. It just dumps a lot of text on you. Like there's a lot of it, and it can easily overwhelm the model. And like you don't need all of this. Like the most of it will be the service reached steady state. The service reached steady state. There will be like a lot of garbage in there. And like, but if you have a better tool that can filter out all, like, which will be aware of all the stuff and can filter it out and give the model only what it needs, the model will be able to come to the better results, trying to figure out what it is, because it's not getting confused by all the noise. It's the same like with the logs, right? So you can also use AWS CLI to read the logs. You can use AWS MCP server to read the log, but still you need to get all the parameters right. But if you have a tool that already gets the parameters right and filter out all the noise, the model gets a better output and able to give you the better judgment. Well, I shouldn't be saying that giving the judgment, but like the regurgitation of what it saw in the logs.
No, true. Yeah, I think that connects with the other episode we had about context, right? And this is one of the things, you save context by not dumping a lot of stuff in there. Yes. And in a very practical way, right? For someone listening or watching, is in the main message is just the pure model. It's not enough, right? So if you build these toolings around, like you're mentioning, Andrey, then you start leveraging the model in a much better way, getting more results. And for the stuff that we do as DevOps engineers, like it's always, reliability is always important, right? You're managing infrastructure. So if you build these tools to enable the agent to help you in a more deterministic way, or at least a smarter way, then you can get way better results than just going with a raw tool. Let's say just use Claude Code or Kiro, but just like no tools, just the CLI and pure thing. Right. So the harness is very important, right, for better outcomes.
Yeah, so people might be a little bit annoyed with us because we did like 4 episodes now talking about conceptual things. But as we can see, they're important for us to have more advanced discussions. So we need to iron those out. I think we have hooks left. Maybe we should talk about the memories, RAGs and graphs RAG and all of that. And then we can actually start to talk about the application of the harnesses with all the tooling to what you can do in the DevOps. So that's coming. We just establishing foundation.
Exactly.
All right.
All right.
Any last word, Vladimir?
No, I just the word of a harness. It's a bit related to horses. So it's feel a bit Asian to me. So I ride horse once for a whole day, but why people not call it steering or something more modern?
What would you call it?
Like a riding. I don't know. It's kind of hard because it's kind of control another entity, but it's not a human. It's not biological. So it's a kind of programmatic controlling robots. How we call controlling robots? Harness.
Yeah, I think it's quite common. Like you have test harness, like where you control the test. So I think the term is quite common.
Just comes from there. Nice.
All right. Another episode in the books. Thanks everyone who tuned in, especially to those of you who listened till the end. We love you. Thank you for that.
Yes. And we'll see you in the next one.
Thank you for tuning in. Bye-bye.
Bye.